The 6-mark bonding question here. Now these are very common. In fact, this one is almost identical to the one previously, so that tells us that these questions have come up almost identically on subsequent Edexcel papers. So we've got 3 substances here: copper, carbon diamond, and iron chloride. It doesn't tell us which is which, so we have to identify those. Copper, that's a metal, so we're looking for something with high melting points. They've all got high melting points. We're looking for something that conducts electricity in the solid state and in the liquid state, so that has to be B. Carbon diamond, extremely high melting point, doesn't conduct electricity in the solid state, if you can't melt it, because when you get to the point of breaking the carbon bonds, it turns straight to a gas, so that's sublimes. That means it turns straight to a gas. So number 1 is diamond, which means number 3 has to be iron chloride. Iron chloride, metal, non-metal, ionic. So that's a high melting point. Poor conductor in the solid state, because the ions can't move, and good conductor in the liquid state. So 3 is iron chloride. So let's write that down straight away here. 1 is going to be carbon diamond. 2 is going to be, we said, copper. And 3 we said was iron chloride. Now we need to explain why we've made those decisions in terms of melting point and conductivity. So we need to explain melting point and electrical conductivity for each and every one of these, and just go through them one at a time. So we'll do carbon diamond here first. Carbon diamond, very high melting point. So it's a very high melting point, and the reason is each carbon, even before we say that, let's say it's a giant molecular structure, giant covalent structure. We do need to state the type of structure for all of these. So in that giant covalent structure, each carbon is held in place by 4 strong covalent bonds. And we then need to say it takes a lot of energy to break those bonds. And it's a poor conductor because to be a good conductor you need charged particles that are free to move. A current of electricity is a flow of charge. So it's a poor conductor because there are no delocalized electrons. So metals conduct because they've got delocalized electrons, as does carbon graphite, or no ions. And ionic substances conduct in a liquid state because they have ions that can move. So we need to say copper is a metallic bond. We need to say iron chloride is an ionic bond. Okay, so as I said, this question is almost identical to the previous one, so let's just go back up to the previous one. And here we had iron, that was the metallic bond, and we said the iron was metallic because it had a melting point that was high because strong forces of attraction between positive metal ions and electrons, which are delocalized, the delocalized electrons. It takes a lot of energy to separate those ions and electrons. So metals have a regular arrangement of positive metal ions surrounded by delocalized electrons, and there's strong forces of attraction between those positive metal ions and those negative electrons. Metals conduct because they have delocalized electrons which are free to move. And the ionic substance we had here was sodium bromide. Okay, the ionic substance we have in our question down here is iron chloride, so we need to say for sodium bromide it's ionic, or in this case iron chloride is ionic, and it has a high melting point. Why? There are strong forces of attraction between the positive and negative ions in the ionic lattice. It requires a lot of energy to separate them. It's a poor electrical conductivity in the solid because the ions cannot move because they're held in the ionic lattice, but it does. It is a good conductor. It's a good conductivity when molten because the ions can move. So as I said, identical answer to the previous one. I'm not writing it out this time. All these questions on ayleshamhighchemistry.com.